To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello, my dear students. Welcome to today's lesson. So, these are the questions given in your textbook, that is exercise related to the 10th lesson. That is the household electric circuits or domestic electric circuits. In the lesson, if you can remember, we discussed different electric appliances where there is electricity being converted to different forms of energy. Then we discussed how to calculate the power of an electric appliance and also the energy consumed by an electric appliance. Thereafter, we discussed how efficiently we can select different electric appliances that are available for the same purpose. So, for example, if it's the light bulbs, there are different types of bulbs. How to identify the most efficient bulb and how to use it to use electricity efficiently. And thereafter, we discuss the different components present in a household electric circuit and their functions. And you were able to see them in the lab as well. How they work or how they look like, you are familiar with all that. And finally, we discuss different protective measures that can be used to protect the residents and to prevent accidents happening due to electricity. And the units that are used to calculate or determine the amount of electric energy that is used by a consumer. So, all those were covered in the lesson in the previous chapters. So, now the exercise. I am sure you all would have already answered the questions by yourself. If not, you all answer the questions by yourself first and then you compare your answer with my discussion. So, I am going to start discussing the questions. Exercise. The first question. The power of an electric water pump is 750 watts. First one, A part. Calculate the current drawn by the motor if it is connected to a 230 volt supply. The potential difference or the voltage is 230 volt. Power is 750 watts. Then the B part. State one type of energy other than the kinetic energy generated when the motor is operated. So, those are the two questions. We will answer them one by one. So, the first part of the question, that is A part. A part of the question, you need to find the current drawn by the motor. So, what is the equation? Three quantities, power, voltage and current. So, what is the equation? Power equals voltage into current. So, here power equals voltage or potential difference into current. That is P equals VI. Now, students, when you all are doing the calculation, you don't have to write the equation and in words and symbols. You can directly use the symbols and you do the substitution and calculation. But for you all to recall and remember, I have written both. So, power equals potential difference into current. We know the power. So, you can first substitute and rearrange or rearrange and substitute. I will substitute first. 750 watts of power is consumed by the electric water pump and the potential difference across it is 230 volts. We need to find the current. So, how do we do that? I equals 750 divided by 230. You will get the answer in amperes. So, if I do the calculation, 750 divided by 230. So, 750 divided by 230, we can cancel off the zeros. So, 75 divided by 23. So, you can see 3 times. 3 into 3, 9, 3 into 2, 6, So there are 6. So decimal 60. So then of course you will have 2. So it is going to be 6, 4, 46, 14. So that is going to be 140. Then of course you can have 6 times. 6 times 6 into 3, 18, 1, 6 into 2, 12, so 13, 140 minus 138, 2. So then of course it becomes 20, then 0, 200. We can stop with the second decimal place, 3.26. So that is the amount of current. So here we have the value 3.26 amperes. 750 watt power, 230 volts potential difference. So the current drawn is 3.26 amperes. Is that clear, student? So that was the first question. Calculate the current drawn by the motor if it is connected to a 230 volt supply. So power equals potential difference into current. So power is 750 watts, 230 volt potential difference into current. When you rearrange, you get the value as 3.26. Like I have told you all before, you can also rearrange first. You have the equation P equals VI. You can rearrange it, make I as the subject of the equation. So you will get the equation as from P equals VI. You can make I as the subject. So you will get the equation as P divided by V. Then you can substitute and do the calculation. Either method is fine. It gives you the same answer. It's basically the same calculation. Just the way, the order in which you do the rearrangement is different. So both methods are fine. That is for the first question. Then the second question. State one type of energy other than the kinetic energy generated when the motor is operating. So we have discussed this before. Now when an electric appliance is operating, electric energy is converted to another form of energy. So in a motor, electric energy is converted to kinetic energy while the motor rotates. So in a water pump, the motor, or inside a fan, there is a motor. In all those, there is rotation. So there is kinetic energy. In addition to that, you all know, students, most of the electric appliances, they have internal resistance. So what happens when there is internal resistance? Part of the electric energy that is consumed is used for the internal energy, and that is converted to heat energy. So always or mostly in devices, in addition to the main energy conversion, there is heat energy produced. Now, if it was a water pump where you hear a sound, then of course you can say electric energy is converted to sound energy. But normally if it is a motor, now here this is of course a water pump. Yes, if you hear the sound, there is sound energy produced. But you can be sure that there is heat energy produced. Now if it is a motor in a fan, then of course usually you don't hear the sound unless the fan is rusted or there is dust accumulated in it. You don't hear a sound when it is working. So there of course you cannot really mention the sound energy, but you can confirm and say that there is heat energy produced. So here, state one type of energy other than the kinetic energy generated when the motor is operating. So that is the second question. B part of the question. So I will say heat energy. So instead of sound energy, if it is a very good condition, new motor, usually you don't even really hear it working. There will be a slight sound, but compared to that, you know there is heat energy produced because of the internal resistance. So that is why I have given that answer here. I am sure you can understand that. So with that, we'll move on to the second question. Specifications of a flashlight bulb are given as 2.5 volts and 0.3 amperes. What is the power of this bulb? B part, if the efficiency of emitting light from this bulb is 42%, what will happen to the remaining 58%? So to answer the questions, A part, now they want you to find the power. The values that are given are potential difference and current. So what is the relationship? Power equals potential difference into current. So here, of course, I will only write the equation P equals V into I, because already I have written the word equation also. So P equals V into I. So voltage is given to you as 2.5 volts and current 0.3 amperes. So to calculate that, 2.5 into 0.3, a direct calculation, direct multiplication, you get the value as 0.75 by 2.5 into 0.3. So 5, 6 and 1, 7. There are 2 decimals, so 0.75. 0.75, what is the unit of power? It is watts. Voltage V into volts into amperes is watts. 0.75 watts. What is the power of this bulb? Then the B part. If the efficiency of emitting light from this bulb is 42%, what will happen to the remaining 58%? What happens? It is converted to heat energy. Why? Because there is internal resistance. So that is what you have to write here. B part, the remaining 58% is converted to heat energy due to internal resistance. So that is why the efficiency is only 42%, less than half efficiency. So you all have to understand that. So that is why we have to select the correct electrical appliance, or here it is a light bulb that is more efficient. Is that clear to you? So the first question was to calculate power using voltage and current. So P equals VI, 2.5 volts into 0.3 amperes. You get the answer as 0.75 watts. And B, the remaining 58% is converted to heat energy due to internal resistance. That is because they have said only 42% is used as emitting light. But what happens to the rest of the 58%? So that is converted to heat. Is that clear, students? So with that, I'll move on to the next slide. Question number 3. The power of the 2 headlamps of a motor vehicle is 50 watts each. So there are 2 headlamps, 50 watt each, and there are other 2 lamps in the rear with 10 watts each. Another 2 lamps with 10 watts each. If all these bulbs are lighted up for half an hour, calculate the quantity of electric energy spent. Now, normally electric energy spent, what is the equation? Power into time. So, here the power is given and the time is given. So, power 2 lights with 50 watts, and that is for half an hour. Now, half an hour, you can even take it as 0.5 hours, or you can take it as 30 minutes. But either way, you will need to convert it to seconds. Because energy, you know the equation, students. Power into time. Power has to be in watts and time has to be in seconds. Now, you have to be clear, students. When we do the calculation for the commercial unit, there we use the unit kilowatt hours. There, of course, you can directly use the hours as it is. But for calculating the quantity of electric energy spent, you have to have the time in seconds. That is the standard unit. So, don't confuse that. Be clear with the two different calculations. This is to calculate the electrical energy spent. So, then another two lights at the rear with 10 watts power, that also for half an hour. Then you need to calculate energy. Energy, again I am writing the equation, power into time. So, E equals P into T. Just for you all to recall. Then you need to calculate the total energy. So, for the two sets of bulbs, you can either do them separately and add them together, or you can calculate it together. So, I am going to calculate it together. E equals, you have 50 watt bulbs into 30 minutes into 60 seconds. You have to convert it to seconds. Like this, we have 2 bulbs. Plus, you have 10 watt bulbs that is also being used for half an hour, that is 30 minutes into 60 seconds, and there are 2 bulbs. So, here, what we can do is, we can take either the common factors out and do the calculation, or directly multiply and calculate. So, here if I calculate 5 into 3, 15, 15 into 6 is going to be 90, 90 into 2, 180, but there are 3 zeros. 180,000 plus 18 into 2, 36 and 36,000. So, that is how we can calculate. This is going to be in joules. Why? Power watts into seconds is going to be equal to joules. 1 watt second is 1 joule. So, here if we calculate 180,000, 36,000. So, when you add them together, 621, 216,000 joules. Or we can write it as 216 kilojoules also. 1000 joules is equal to 1 kilojoule. That is also correct. So, like I said, we can do the calculation like this. Or else, what you can do is, you know the power of the 2 bulbs. You can add them together. Each type, 2 bulbs, you multiply by 2. And then you can multiply by time. Either way is fine. But this is the most easiest way, because if they change the number of bulbs or the amount of time it is being used, then of course this method is more convenient to calculate. So, we will stick to this method. 50 watt bulb used for half an hour, that is 30 minutes into 60 seconds. There are 2 such bulbs, headlights. Then the rear lights, 10 watts, again half an hour, 30 minutes into 60 seconds, and that also 2 bulbs. So, when you multiply 50 into 30 into 60 into 2, you get 180,000. And 10 into 30 into 60 into 2, you get 36,000. When you add them together, you get the answer as 216,000 joules or 216 kilojoules. Is that clear, student? So, with that, I am going to move on to the next slide. Question number 5. We will answer one question at a time. The first one, A part, name 2 instruments that are used in a domestic circuit for the protection of the residents. So, you know 2 instruments that are used. One is the RCCB, residual current circuit breaker, or the trip switch. The other one is the MCB, miniature circuit breaker. So, those are the 2 components or 2 instruments that you have to write here. Name 2 instruments that are used in a domestic circuit for the protection of residents. Residual current circuit breaker, or what we call as RCCB or trip switch. So, when you all write the answer, students, you can write just one name. You can say residual current circuit breaker or RCCB, or you can write it as trip switch. Then we have the miniature circuit breakers, or MCBs, or you can call it as fuses. Again, here of course it is better to use either miniature circuit breakers or MCBs, because in the modern household circuits we use the MCB, not the fuses. The old houses had the fuses. So, RCCB or trip switch and MCB are 2 instruments used in the domestic circuit to protect residents from accidents due to electricity. Then, the second question, part B, mention what is the type of protection provided by each of them. What does the RCCB do? It protects the residents from electric shock. And the other one, it protects the fire caused by current that is more than 30 amperes. Overheated cables, prevents overheated cables and fire caused by electricity if the current flow is more than 30 amperes. What does the MCB do? MCB, maximum current either 6 amperes for light circuits and 13 amperes for lamp circuits. There also, it protects the residents from fire accidents caused due to heated cables. Electric shorts or fire caused by heated cables. So, that is what you need to write here. Mention what is the type of protection provided by each of them. So, RCCB, and say protects from electricity leakage and current more than 30 amperes. So that is fire caused by heated cables. Then we have the MCB that protects electric shorts or fires caused by heated cables. So here of course they have not asked for explanation. So you don't have to write down the values for lamp circuit, that is 6 ampere, plug circuit, it is 13 ampere, all those information are not necessary. But here I have mentioned 30 amperes because that is a somewhat high current compared to the miniature circuit breakers. So that is more than enough. Then, the third part of the question, that is C part, explain what is to be done to protect electric equipment in a house when lightning occurs. So you have to remember, students, sometimes the RCCB cuts off the power to the household when there is lightning. But that is not ensured by the RCCB because that's not the function of an RCCB. So what should you do? You have to turn off the television, radio, especially those are the devices that get signals. They receive signals. So they have a high tendency to receive the lightning as well. So you have to switch them off, unplug them, and also you have to avoid using unwanted electrical appliances. So that is how you protect electric equipment in a house. So you can say switch off and unplug equipment like television and radios. Do not use unnecessary electrical appliance during lightning. So those are the methods by which you can protect the electric equipment in a house when lightning occurs. Switch off and unplug equipment like television and radio. Do not use unnecessary electrical appliance during lightning. You can even say during lightning. So that is how we can protect the household. Is that clear, students? So I'm sure you would have answered them correctly. So with that, I'm going to move on to the next slide. Question number 6. Consumers are charged money for the electricity used in houses. What is the unit of electrical energy which is used to make electric bills? Commercial units, 1 kilowatt hour is equal to 1 unit. So here, kilowatt hours, or you can write it as kilowatt hours. Normally, watt, W has to be in capital. So if you write it in symbols, units like this, K simple, capital W, and H simple. But when you write it in words, kilowatt is one word. So you don't have to use a capital letter there. Consumers are charged money for the electricity used in houses. What is the unit of electrical energy which is used to make electric bills? It's kilowatt hours. Then, the next one. Calculate the amount of energy in joules equivalent to 1 commercial unit of electricity. So, 1 commercial unit of electricity, 1 kilowatt hour, that is equal to 1 into 1000 watts into hours have to be converted to seconds. So, that is going to be 1 into 60 into 60 seconds. That will give you the value in joules. So, 6 into 6, 36. And there are 5 zeros, joules. So, 3,600,000 joules. So, 1 kilowatt hour is equal to 3,600,000 600,000 joules. Or they have asked in joules equivalent, so we don't convert it to kilojoules. Don't convert it to kilojoules. Calculate the amount of energy in joules equivalent to 1 commercial unit of electricity. So 1 commercial unit is kilowatt hours. 1 into 1000 to convert it to watts, and 1 into 60 to convert it to seconds, in seconds. So this is 1 kilowatt used in 1 hour. We need to find the energy, the watts, number of watts used in seconds, into seconds. So that is the energy. You all can remember that in joules, that is how we calculate. So 3,600,000 joules. The next question. If the first 60 units are charged at a rate of rupees 750 per unit and the next 30 units are charged rupees 10 per unit, how much will be the electricity bill of a house where the electricity usage is 75 units? So the household uses 75 units. Out of that, the first 60 units are charged at a rate of 7.5 per unit. Then when the first 60 units are taken, thereafter you have 75 minus 60, that is going to be only 15 units. So these 15 units are going to be charged at rupees 10 per unit. This is just I am writing and showing you all how we should do the calculation. Out of the 75 units, the first 60, 7.5. Then when you subtract from 75, 60 units are gone. The next 15 at the rate of 10 per unit. So the bill for the month. So the bill value is going to be 60 into 7.5 plus 15 into 10. So that is going to be, if we multiply 60 into 7.5. So there are 0, 30, and 0, 0, 42. No, 0, 0, 5, 4. 450 rupees. So there, this is going to be 450 plus 150. So the total value will be 600 rupees. So the bill amount for the month is going to be 600 rupees. Is that clear, students? So that is how we do the calculation. You have to look at the total number of units, how they are divided into segments and how they are charged differently. First 60 units, 7 rupees and 50 cents. The next units at the rate of next 30 units at the rate of 10 per units. But out of that, only 15 units had been consumed. So accordingly, we do the calculation. I am sure you all also can do this calculation. So with that, I will move on to the next slide. So question number 7. The power of a water heater in a home is 1500 watts. So here again, you all have to note down the value, students. The water heater, the power is 1500 watts. This is used for half an hour daily. So when we say half an hour daily, you all know you can't directly use it as half an hour. We have to take it as either half or 0.5 is more convenient. So this is going to be 0.5 hours. 340 watt bulbs are used for 3 hours daily. So there are 340 watt bulbs and they are used for 3 hours daily. And then you can see 2 bulbs of 60 watt are lighted for 2 hours daily. calculate the number of units used up in 1 day. So you have to calculate the number of units used up in only 1 day. So in 1 day, water heater 1500 watts, 340 watt bulbs for 3 hours, and you can see there are 2 bulbs 60 watt 2 hours. So that is what you need to calculate. So here if we say units consumed, I'll just say units. You have the heater 1500 watts into it is used for half an hour. So it has to be 0.5 hours. Plus, because you have to add up the power consumed by electric energy consumed by all the devices separately. Then we have 3 bulbs, 40 watts, and they are used for 3 hours, and like that there are 3 bulbs. So then what do we have? We have 2 bulbs, 60 watts, lighted for 2 hours. 2 bulbs, 60 watts, lighted for 2 hours daily. So 2 bulbs, 60 watts, lighted for 2 hours daily. If you check again, now there is the water heater 1500 watts used for half an hour, 0.5 hours, or you can have it as half also. Plus we have 3 40 watt bulbs, 40 watt bulbs, 3 bulbs used for 3 hours per day, and 2 bulbs 60 watts used for 2 hours daily. So we need to add all these values. Now 1500 into 0.5 hours, that is 750 watt hour. Plus we need to have 40 watts into 3 into 3. So that is 3 into 3, 9. 9 into 4. 9 into 4 is 36. So 360 watt hours. Then what do we have? We have again 2 bulbs, 2 hours, that is 4 into 60, 240 watt hours. Now here you have got the answer in watt hours. But if you need the number of units, what should you have? You need to have it as kilowatt hours. So to convert this to kilowatt hours, what should we do? Now here the whole thing should be, we have to divide this by 1000. We have to divide this by 1000. So that we get it in kilowatt hours. So there, if we look at the calculation, you can see 750 plus 360 plus 240. So that is going to be 1350 divided by 1000 kilowatt hours. So that is equal to 1.35 kilowatt hours. That is 1.35 units. Or you can write this as 1.35 units. Since they have asked the question as calculate the number of units used up in 1 day. 1.35 units, or that is equal to 1.35 kilowatt hours. Is that clear, students? So according to the question, there are 3 devices, the heater and 2 different types of bulbs. So you write them separately and add them together, and you have to make sure that you divide by 1000 so that we get the answer as kilowatt hours. Is that clear to you all? So then we'll look at the next question. Second part of the question, B part. If electricity is charged according to the above rates given in the question 6C, that is the previous question, what should be the monthly electricity bill? So we will quickly go back and have a look at the charges in the previous question. So here you can see the first 60 units are charged at a rate of rupees 750, and the next 30 units are charged rupees 10 per unit. how much will be the electricity? So that is for this question. What you need to know is first 60 units rupees 750 and the next 30 units rupees 10. So here if we write that first 60 units 7 rupees and 50 cents and the next 30 units 10 rupees. So here how many units are there? We have 1.35 units. That is for 1 day. You have to remember students, there we have calculated only for 1 day. But here it is for the monthly electricity bill. So what do you need to do first? You need to multiply the number of units by 30 days because 30 days is 1 month. So here units used in a month, that is equal to 1 day is 1.35 into 30. So if you calculate that 1.35 into 30, 1.35 into 30, we have 15, 9, 10, 3, 4. So the value is going to be 40.50. So here the number of units are 40.50 units. So 40.50 comes within the first 60 units. First 60 units at a rate of 7 rupees 50 cents. So that is how we calculate the charge. So their monthly charge or monthly bill we can say equals 40.50 units into rupees 750. So again if we calculate that, so here you can see 40.50 into 750. So here this is going to be 25, 2 and 20. And then I have 0, 35, 3 and 28. So here we will have a value of 3, right. So if we consider the zeros, this is going to be 303 rupees and 75 cents. So there the bill value 303.75. You can write it as 303 rupees and 75 cents. Is that okay, students? So we did both the calculations. Here this is to find the monthly electricity bill. It is according to the previous question. First 60 units 7 rupees and 50 cents. Next 30 units 10 rupees per unit. So the number of units used in a month has to be calculated. Because in the previous question we calculated the number of units used in 1 day. So here you need to multiply by 30 days. So we get the answer as 40.50 units. And then to calculate the monthly bill, if you look at the number of units, it's within 60 units. So there are 40.5 units into 7.5 rupees. So that gives you a value of 303 rupees and 75 cents. So I'm sure you all also were able to do this calculation. So if we quickly look back, you can see this is to calculate the number of units used in 1 day by 3 different devices. So you have to remember, students, you have to consider the devices separately. You have to add all the values And also you have to make sure that you divide by 1000. Why? You need to have the units as kilowatt hours. 1 unit is 1 kilowatt hour. Then according to the given rates, you need to calculate the value for the monthly electricity bill. And there also you have to remember you need to multiply by 30 days because 1 month is 30 days. Is that clear, students? So then I will move on to the next question. Question number 8. A part, a hot plate or immersion heater can be used to heat water. Which one is more efficient out of these two? Which one is more efficient? The immersion heater. Why is that? Because there you immerse the heater into water. So all the heat that is produced is supplied to the water. It is not lost. But whereas in a hot plate, it is efficient, but still there is a chance of a little bit of heat being lost. So the most efficient one is the electric immersion heater. So here it is the immersion heater. Give the reason for this. So what I just told you. So to give the reason, we can say the immersion heater is immersed into water. Therefore, all the heat is supplied to water. But in a hot plate, there is a possibility of a small amount of heat loss. Why? You keep the vessel on the hot plate. So from the hot plate, heat is given to the vessel. From the vessel, heat is transferred to water. So from the walls of the vessel also, there's no chance of losing heat. But when you put the immersion heater into water, from the immersion heater, directly heat is given to the surrounding water. So thereafter only it will be lost to the environment through the walls of the vessel. So because of that, immersion heater is more efficient. Then the next question. What is the reason for using 3-pin plugs instead of 2-pin plugs for immersion heaters? Now immersion heaters, we are putting it into water. So there is a chance of electricity leakage. So if there is an electricity leakage, it has to be earthed and it has to be connected to the RCCB, residual current circuit breaker. So because of that, you have to use a 3-pin plug. Is that clear, students? So what is the reason for using 3-pin plugs instead of 2-pin plugs for immersion heaters? You can say they are immersed into water. Therefore, there is a chance of electricity leakage. Then the RCCB should disconnect the power supply. or we can say electricity supply. Disconnect the electricity supply when earth wire is connected in a 3-pin plug. So in a 2-pin plug, there is no earth connection. So there's no connection to the RCCB. So it will not protect the residents from getting electrocuted. So because of that, you have to use a 3-pin plug. You have to keep that in mind. Then the last question of the exercise. When an electrical appliance is switched on, the electrical circuit was disconnected. Give 2 reasons due to which this can happen. What are the 2 reasons? It can be either disconnected due to the RCCB if there was a electricity leakage, or it can be due to higher amount of current flowing through the circuit. If it is the RCCB, more than 30 ampere current. If it is the miniature circuit breaker, that is the MCB, any current more than 13 amperes, the appliance will be disconnected. So 2 reasons, either electricity leakage or high current more than the maximum value. So when an electrical appliance is switched on, the electrical circuit was disconnected. Give 2 reasons due to which this can happen. Electricity leakage, or you can say excess current, or in other words we can say current more than the maximum value. Example, RCCB more than 30 amperes, MCB more than 13 amperes. Now this, of course, students, it's not a must to give the value of the current. If you just say excess current, it is fine. But for you all to remember and understand, I have given this additional information as well. So this is the answer. If electric circuit was disconnected, then it could be one of the 2 reasons. Electricity leakage, then also the trip switch or the RCCB, residual current circuit breaker, will cut off the electricity supply. If it is excess current more than 30 amperes to the circuit will be cut off by the trip switch. Only to the electric appliance it will be cut off by the MCB. So that is how the devices are protected. I'm sure you all can understand that. So with that, students, I have completed the questions given in your textbook. So with that, I'm going to end this chapter, and in the next chapter, I will discuss some extra questions related to this lesson.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.